Okay, so we're going to solve this problem. Okay, and so here we have the tension is given, which is this one, horizontal 30 degrees. So there, and we're going to mark that T1. Okay, that's given. And then we have another chord here, and that has a different tension, so we're going to mark that T2. Now these are both vectors, okay? And here, this is your weight, right? And therefore, we're going to mark that too and call it Fg. And what you're supposed to look for here is find the weight. Box Fg. Okay, so you write that A. We're looking for Fg in newtons. Okay? All right. Now, I recommend that you make a free body diagram, which means you rewrite just the arrows. Okay, so you have the arrow going down. Okay, that's your Fg, right? And then you have this one going here. Okay, and that's your that's your T1, right? Put an arrow. Okay, and then you have another one up there, 50 degrees going this way, and that's T2. Okay? All right. So what is your basis here? The summation of all forces along the y is equal to 0. Summation of all forces along the x is equal to 0. What does that mean? It's not moving. So it's not going to go up or down or left or right. So these forces are going to be equal. Now what you're going to do, if you have, right, if you have a vector that's diagonal, meaning you have to resolve this into x and y. So actually you will have one here. This is called T2y. And then another one here. And this is going to be T2x. Correct? And once you have resolved that, you don't think about this one anymore. And what is the formula for that? Okay, you have here T2x is equal to T2 times, look at that, the x is not touching and therefore sine of theta. Then you have T2y, T2 cosine of theta. And why is it cosine? It's touching. See this arc? This is touching this and that one, and therefore that's the cosine. Okay, that's what I told you. If it's touching, it's a cosine. Now look at this again. You now have four forces. Fg, T1 is going this way, going up is T2y, and going this way is T2x. Okay? Look, horizontal. The summation of forces along the x is equal to 0. What does that mean? Right is equal to left. So T1 is equal to T2x, right? This must be equal to that because it's not moving, and those are the only two forces, left and right. So we're going to substitute our value for this, and that becomes T2 sine of theta. Okay? And now we're going to solve for T2. T2 is equal to T1 over sine of theta. Okay, you just rearrange these two. And you're going to have T1 is given 30 newtons divided by sine of 50 degrees. And the answer for that is 39 newtons. Okay, do this twice and verify that that's correct. All right, so that's one. And now we're going to do the vertical, which means the summation of forces along the y is equal to 0. And what does that mean? The one going up is T2. T2y is equal to Fg, which is the weight, right? Again, put all of those little arrows. That means that these are all vectors, okay? And what does that mean? Your T2y is this one here, which is T2 cosine of theta, which is equal to Fg, correct? And what you're looking for is Fg. So therefore, Fg is equal to T2 cosine of theta, which is that one. And T2 is 39 newtons, cosine of 50 degrees. And the answer to that, Fg, is going to be 25 newtons. Check. I hope that's clear. Now, just look at this, okay? This one is equal to that one, which is what is stated here. See? This one you're going to replace with the formula, which is T2 sine of theta. Okay? And here, the weight is equal to the y component of the T2. So here, Fg is equal to the y component, or using this formula, you have that, right? When you see this sign that I use, that means transition. You're rearranging the formula. Okay? I hope that's clear.